triangles and bisectors. Let's start with the learn with an example to explore one of the key ideas. A point is equidistant from two lines if it is the same distance from them. The distance between a point and a line is the length of the segment perpendicular to the line from the point. The angle bisector theorem states that a point is on the bisector of an angle if and only if it is in the interior of the angle and is equidistant from the sides of the angle. So, given this angle here, WXY, and we have XZ here bisecting the angle, okay, we can see here that this angle is the same size or congruent to this angle, okay? Therefore, this is the bisector here. So Z is on the bisector. Z is a point on this bisector of angle WXY, WXY, if and only if it is on the interior of angle WXY and WZ is congruent to YZ. So therefore, WZ has to be congruent to YZ in order for us to conclude that this is an angle bisector. Not only are these two angles congruent, but these segments here are also congruent. Okay? Let's go ahead and take a look at this example. If angle EGF, find EGF, okay, that's this angle inside here, is congruent to angle EGF. Let's find EGH, excuse me. That's this angle on this side. So we're talking about this first angle and then this second angle. If those are congruent and EF we're told is 97, then what is EH? Okay, we can conclude now this is the angle bisector, and therefore this segment has to be equal to this segment. So it would be 97. EH is equal to EF, therefore it is equal to 97. Let's try a few problems on our own. What is CD? So now this is actually the perpendicular bisector problem we're given. Let's explore this example and see if, no, they don't give us the example here, but the idea is the same. Perpendicular bisector. The perpendicular bisector is cutting this segment here, BD, in half. Bisector, meaning it cuts it in half, just like the angle bisector cut the angle in half, and therefore BE is congruent to ED, and perpendicular in this case, meaning this line forms a 90-degree angle or four 90-degree angles with this line here, or line segment. Okay, so now when that is true, not only will these two segments be congruent, these segments here will also be congruent. That is segment BC and CD. So if BC is 57, CD also has to be 57. So we'll practice both, using both the perpendicular bisector, as we just did, theorem, and the angle bisector theorem. So now here's the angle bisector theorem, which we looked at in the key idea. We have the measure of angle WXZ. Where's WXZ? Let's find it. WXZ, that's this angle in here, is 42. And we are looking for what is the measure of angle WXY, that is WXY. WXY is the complete angle of this and this. So if this is 42, this is 42. Therefore, the complete angle is 42 plus 42, 84. So in some cases, we need to add up or double up the angle measurement. In some cases, we just have to set it equal. So here, just glancing at the image given to us, we see that this angle is being bisected by RT. That's why we have a 52 degree here and a 52 degree for a total of 104 degrees. And here, this segment, RU, is 89 degrees, or excuse me, just 89 and units, and therefore we are looking for RS. So RS, we can conclude, is the same as RU, 89 units. Okay, if ij is congruent to jk. Where's ij? Ij is here. That is congruent to jk. And hi is 81. Hi is here. That is 81. What is ik? Ik is the complete segment below. So if this is 81, if hi is 81, we can conclude hk is also 81. Therefore, ik is the sum of this 81 and 81. So 81 plus 81, 162. These problems will get a little bit trickier, but what gets tricky is just using algebraic equations to solve the missing pieces. And we'll see that in a couple problems. Now, we're given 60 degrees here, a 15 of 15. You'll start catching on that even without starting to look at the question, you'll be able to figure out some of the missing parts. Like here, we can start assuming this will be 60 degrees, but don't make assumptions immediately until we can conclude that we could actually use the theorems that we're learning about. Okay, so here we know that this measurement is congruent to this one, and therefore this segment we can conclude is the angle bisector. So can we use the angle bisector to solve for the measurement of angle EDF? Where is EDF? EDF is here. Can we come up with an angle measurement here? Yes, we can conclude that is 60 degrees. So yes, we can use this theorem. Okay. Can you use the angle bisector theorem to solve for WZ? Can we figure out WZ? Let's see. If this is 27, can we assume this is 27? Well, can't always make assumptions. The reason why we can't make this assumption here is all we are given is 27. We do not know for sure that this angle here is equal to this angle. In other words, angle XYW, we don't know whether that is equal to angle WYZ. We cannot assume they are. If we knew both of these were, say, 15 degrees, then we could conclude that if this is 27, this would be 27, but we don't have enough information. Therefore, we have to conclude, no, we cannot use the angle bisector theorem. So never assume. Can you use the perpendicular bisector theorem to solve for FG? FG here. Again, the only measurement we have right now is 34. We don't know. Actually, in this case, we do know this angle. We have 90 degrees. Therefore, this is 90 degrees. So we can conclude this is perpendicular. Now, actually, we don't know this here. That's what we were missing. We're missing the measurements of this segment and this segment. Okay, I concluded that this is perpendicular, right? Because they form a 90-degree angle. However, we don't know the measurement of EF or EH. Therefore, we can't assume they are equal to each other. Even if they look like they're the same size, they can be off by 0.1 or 0.01, just a fraction of a value. So you can never assume. We have to conclude that we don't have enough information. Therefore, no, it is perpendicular, but we cannot assume it's a bisector, so we cannot use the theorem for now. No. So notice, as I thought aloud through that problem, I went back and forth until I dug into look for the evidence. And that's what you have to do with these problems. Make conclusions until you have the evidence. Okay, can you use the perpendicular bisector theorem to solve for HK? HK. Okay, so here, this is perpendicular to this here. And can we use it to solve for HK? Can we assume that these are the same? Again, we cannot assume that these are the same in size because we don't have enough information. So let's go ahead and click no. What is the value of S? Okay, these are the ones that I was mentioning would get a little bit trickier. Now you have to use the same concepts, but apply your algebra, solving equation, and writing equation skills. So now we have this angle bisector, and we can assume or conclude that it is an angle bisector because this angle is congruent to this one. And now here we have S plus 32 has to equal 3S. So you would create that equation, s plus 32 equals 3s. Use some scratch paper to go ahead and solve this. So I will use this here. It was s, well, it's a little tricky writing on this, s plus 32, set that equal to, and you can always glance back, that is 3s, that is your equation. If you can create your equation, you're halfway there. Now it's just remembering your algebra skills to solve. So let's isolate the variable s by getting the s's on the same side first. This s has the bigger coefficient, 3, versus this one, which looks like it has no coefficient, but remember that's an invisible one. So let's get rid of this one s on this side by subtracting an s here. So s minus s, that goes away. If we subtract s there, we have to subtract s on the other side. Excuse this tool here. So we're subtracting s, and what are we left with now? On the left side of the equation, we're left with this 32, and that is equal to 3s minus 1s, or 3s minus s, 2s. So now we're left with this one-step equation. 2 times a number, s, is equal to 32. So if you just use your logic, you can come up with an answer, or you can show the work, divide both sides by 2 to get rid of that coefficient of 2, and that is what cancels that 2, leaving you with s. Again, excuse this tool I'm using here for today. Well, just doesn't want to give us the s today. S is equal to 32 divided by 2, 16. Well, that's the idea. The main thing to remember here is you have to set the expressions given to you equal to each other. So s plus 32 equal to 3s, and then from there it's solving equations. So s is 16, and that's as difficult as these will get. Okay, hope this helps, and remember to help each other out as you work through these problems. Make sure you write these down, because it does get tricky trying to keep track of the steps in your head. And remember, getting one problem wrong will just bring your score down and make you do an extra few problems. So be careful as you work through these problems.